Hi everyone, welcome to the overview of generative models in ML. And my name is Ashit, and let's get right into it. Uh, what exactly is generative AI? Generative AI is a simple subset of the whole machine learning domain, which focuses on just creating new data. The data can be of any type. For example, it can be image data, video data, text data, or simple tabular data, right? Generative AI is different from other domains of machine learning, that is supervised learning, unsupervised learning, so which focus on like supervised learning tries to predict something based on the past data. Unsupervised learning tries to mostly cluster something into unsupervised clusters, and that is how like generative AI is different from the other domains. Uh, what what are the use cases where we use generative AI? One of the very important use cases is image generation. Uh, some of the models that you might have seen in the past 1 or 2 years in image generation is probably DALI and Midjourney. Next is text generation. Uh, GPT is the prime example of it. GPT can not only just generate text for you, it can even generate code for you, right? Um, Next is video generation. OpenAI recently released some clips of their new video generating model called Sora, and another use case is music generation. There was a recent model called, I think, Music LM, which was like a text to music model, where you can type in some text as your input, and the model will try to create some music with respect to what text you gave it as an input. These are some more use cases where you might use generative AI, including Q&A, summarization, paraphrase, etc., audio generation. Right now, we discussed text generation. Usually, LLMs are the best models that you can use for text generation. Uh, Before LLMs, we also had other models which were also language models, but not large language models. We had RNN based models, we had LSTM based models, but those aren't nearly as good as LLMs. What are LLMs? These are deep learning algorithms which can perform variety of NLP tasks, and generally they use transformer based architectures, and they are trained on massive data sets, and hence they are called large language models. um, GPT-4 is one of the most versatile LLMs. It is a fun fact, like it is also multimodal. It can output images and text as well. How do LLMs do all of these things? uh, the next word prediction task is what usually LLMs are trained on. It is an unsupervised learning, where uh, an LLM is fed a large amount of corpus, where it tries to predict the next word in every chunk of data that it gets. And during this process, it it is actually forced to learn a lot about a lot about our world, and how, like, because usually the input data for training LLMs is usually from our own internet. So that is how LLMs are so good at answering things that we try to ask them. These are some of the LLMs which have gotten really big in terms of parameters. Uh, when you see model size, that is the number of parameters that the LLM has. Um, when you see GPT-3 has 175 billion parameters, so it means that it has trained 175 billion weights inside it. Uh, I think Palm is one of the largest large language models. with 540 billion parameters. And this was released around 2022, probably, or in 2023. Next type of generative models are GANs, which are generative adversarial networks. What are these used for? It is usually used to create synthetic data. The synthetic data can be anything from an image to even like a tabular data. Um, how do they work? They inside a GAN architecture, you will probably see two neural networks working side by side. They are actually playing a zero-sum game where uh, the two neural networks are called, one is a generator, one is a discriminator, and the generator is responsible to generate realistic images, which will be our synthetic data, and the discriminator is responsible to differentiate the image from the real image. So the better the generator works, that is, the higher the quality of the images the generator creates, the worse will be the discriminators accuracy. So at the end of the training process, our ideal setup will be that the discriminator is working at a 50% accuracy level, and the generator is able to generate really good images, which aren't really that much different from actual images. Uh, this is what it usually looks like. The generator gets some random input. Usually it is a random vector. Uh, and from this vector, it tries to generate some sample image. And the discriminator takes in this image and the actual images and tries to discriminate whether it is like which one is the actual and which one is the fake. And that is how the loss is calculated for both of them, generator and discriminator. And this is how the training process looks like. The left images are the images generated by the generator, and it slowly gets better at generating realistic images. At the end, it is able to generate a realistic image, and the discriminator tags both the images as real images. That is our final goal. Next type of models is diffusion models. Now, what are diffusion models? These are also generative models, which create new data samples by starting with basic data, gradually transforming it into more complex and realistic data. Now, if you remember from your physics courses, the name has been inspired from non-equilibrium thermodynamics. The basic principle of these models is um, to any image, they add some randomness. That is, they add some random noise onto every pixel of the image, and they do this step by step, and then they try to reverse the whole process and recreating the same image again. That is how a diffusion model is trained. So that is what it says here. Add noise to the original image and learn how to reverse the process. Uh, Two examples of diffusion models is stable diffusion and DALI. This is how the process looks like. The the random noise that this is from this, the diffusion model tries to predict tries to generate a realistic image. That is how the uh, process looks like for a diffusion model. Now, other types of models exist which are called multimodal models. These are the models which can accept or generate multiple types of media. That is, it can be like text and image, text and video. Uh, so if or like all three of them, right? Or text, video, audio, something like that. Text, image, audio. So these are the models which draws outputs from a combination of multiple data types to provide responses and insights, content, and more. These are capable of processing information from different modalities, including image, videos, text. You can also have audio here. Now, how do these actually work? Let's say if we talk about a model which can output text and images. So here the model is sort of trained using encoders. You have two encoders, text encoder and image encoder. Basically, what these encoders do is they try to convert whatever input they get into some vector. So if you give a text input to the text encoder, it will try to convert this into a vector. Same for an image encoder. So let's say you have an image of an apple, and you have the text written apple. Right. So what our model will try to do is the text encoder will convert the text apple into a vector, and similarly the image encoder will try to generate a vector from the image of an apple. And during the training process, what will ideally happen is these two vectors uh, that these both encoders have generated, these will try to get as close as possible in terms of some distance. It can be Euclidean distance, it can be cosine distance, right, or any other distance. So the end goal is that the text encoder and image encoders learn to produce vectors which relate to the same object as close as possible. So if you see in this image, this TA is the vector of apple. This IA is the vector of the image of an apple. And the green box means that these two vectors are very similar in terms of some distance. Similarly, for uh, TA and IC is some other vector of some other image. These two vectors are not supposed to be very close together, so that's why it is red. So red means these vectors are far away. Green means these vectors are very close to each other. So this forms like a diagonal matrix that the values in this diagonal are like very high in terms of similarity, and the other values are very low. And this is what happens. Like the whole model learns to equate the text women with the image of a woman. That is what it is actually doing. And when you try to predict something, so if you input a text, a corgi playing a flame swing trumpet, our model will first encode the text into the vectors, and then convert this into uh, another set of vectors, or a single vector using some weights or whatever weights the model has learned, and then transform this resultant vector into our image, and that is how you get this image. Uh, that is mostly it. This is definitely not an exhaustive list of generative models in AI, but this I tried to give you a kind of a holistic understanding of what all different domains do we use generative models in ML in. And feel free to send in your questions or comments, or just DM me on LinkedIn. And I hope to see you soon. And goodbye.